Hi, this is Involved Innovation YouTube channel. In this video, we will see about Jotai. Jotai is a state management tool which uses atomic state management paradigm. Here, the Jotai uses the individual state units called atoms. It allows for fine-grained state management and reactivity, making it easy to manage both the local and global state. Jotai is inspired from Recoil, which is developed by Facebook, which also uses atomic state management paradigm. Jotai is particularly good if you are using module federation or micro frontend, where you need to share the state across different micro frontends. The key benefits of using Jotai are atomic state management. Jotai manages state in small independent units called atoms. Each atom represents a piece of state that can be read from or written to. Jotai has a concept of derived state where you can able to combine multiple atoms and then you can able to make an atom read only, write only or read and write. And then Jotai is simple. Jotai has a minimal API making state management straightforward. The Jotai is reactive, that is, changes in the atom values automatically triggers the re-renders, ensuring that the UI stays in sync with the state. We will see the following topics in this video. First, we will see about atom and useAtom, and then we will see about Derived-atom. In the Derived-atom, we will see about combining multiple different atoms, what is read-only atom, write-only atom, and then like read and write atom. And then we will see about persisting the state value. With the help of Jotai utilities, you can able to persist the atoms to a local storage or to a session storage. We will see how to persist this to a local storage, and then we will see about async atoms. So here I will use PNPM. You can even use NPM. In your case, if you don't have PNPM, you can install this through NPM. So to install the PNPM, npm install -g is to denote we are installing this globally, PNPM. In my case, I already installed it. I'm gonna create a new Vite project. So for this, I'm gonna use PNPM create and Vite, and followed by this, I will be giving the project name. So here I will use Jotai, and then I will make this as a React project, TypeScript project. So we will go inside the Jotai, open this in the Visual Studio Code dot. So first we will do some cleanup. We don't need the assets folder, delete the assets folder, and then in the app.tsx we don't need this. I'm just deleting this everything here. Open the command prompt here, pnpm install. This will install all the dependencies whatever mentioned in the package.json. To deploy this, we can use pnpm run dev. So this will trigger the script and then it will bring up it in our local system. Now we can able to see we have the Jotai here. That is what we have in the app.tsx. So first we will create the input form.tsx. This is where we will have the text box where we will input the value, and this input value will be stored in the state and used by other components. It only has useState, and useState, the initial value of 0, we have the length variable, and then it has an input text box, and this is a number type. This handle-on change will be triggered whenever you change the values in this input field. As of now, the button doesn't do anything, but this is where we are going to persist in the state. This input form for now is not using Jotai, it is just using the useState, which is only within this particular component. This state is not being transferred to any other component yet. What this application does is it gets this side length and then it calculates the area for the square and then perimeter for the square and then volume. It gets that value whatever we put here in that text box. This value will be stored in the Jotai atom, and from the Jotai atom we can able to get this value to other components, and then we will show that value there. Here you have area. Here this is pretty simple. You have the area, and then you have another field where we will be getting the value from the input form, and then we will be putting it here. Create another component, and I will name this as perimeter.tsx, and this is also pretty much the same. similar to the area, and we will create another component and we will name this as volume.tsx, and here replace all. Now we have input form, area, parameter and volume. I modified the index.css. You can able to see this code in my GitHub repository, the link of which I have provided in the description. So now we will go back to the app.tsx. We need to import all the components. So here we will import everything. So now we have imported the input form, area, parameter, volume. So now we can able to see area, parameter and volume. As of now, if I enter anything here, this is pretty much here. It is not gonna be sent to other components because this area is another component, parameter is another component, volume is another component. This is where we are gonna start with the Jotai. To start with the Jotai, we need to add the dependency. I will add another command prompt, npm add Jotai. So we added the Jotai dependency here. Next, we need to create atoms.tx. So this can be created like in each and every individual component as well, but I want to make it clean, so I will create this atom.ts where we will put all the atoms.ts. So in this case, I will start with the simple atom which persists the side length, export constant. I will name this as side length atom. So this atom comes from Jotai. So if you are gonna use Jotai, you need to know two things. One is atom which comes from Jotai, and then you need to use the useAtom hook. To define an atom, you need to use this atom function. So this atom takes in initial value. So here I will put the initial value as 0. So now go back to the input form. So here we need to use this atom. So here I will use useAtom hook. useAtom hooks takes in the atom. So side length atom. This gives two variables. One is the state itself and another one is a function which is used to persist this information to the state. Whenever I click here, I need to persist this value to the atom. So to do that, set side length function, and I will put the value which we are getting here. So in this case, the value is length. So now what happens is whenever I edit a value here, this gets persisted into this length variable, and once we got this value and once I click the button, it sets the length value to the atom, comma followed by the second argument. So if you put comma, then it will ignore the first one, so that you don't need to use the state and we can just use the function here. So similarly, I will copy this one because this we need for area.tx. So here go back to the area.tx. Here use atom. Side length atom also comes from the atoms. This is side length. So the formula for area is side into side, side square. Copy this, go to perimeter, paste this, and here the perimeter formula is 4a. So 4 into the side length. Now go back to the volume, side length into side length into side length. So now we have used the atom. So I will just quickly go over what we have done. So it is pretty simple. We have created an atom and we named it as side length atom, and for this we use the atom function which takes the initial value, so which is 0 here, which is the side length. And here in the input form we use the useAtom function, and the useAtom function exposes two different things. One is the state and then the setter function. So here we are just using the setter function, set side length, and this useAtom function takes the atom itself. So this atom we are getting it from here which we have created, and then we are persisting the value, the length value, to this side length atom. Once we have persisted this information, this is stored in the global state. Now we can able to use this side length atom anywhere. So for example, here this is another component area where we are using the useAtom, and then we are taking in the side length atom, and then here we are using the first param which is just the state, computing the area based on the side length. So now we can able to see set side length, then I can able to instantly see the square, per meter, and then the volume 64. If I give other value, we can able to clearly see the area is 25, which is 5 into 5, and then per meter is 4 into 5, and then the Q is 5 into 5 into 5. This value setting up in this particular component will be automatically transferred to the atom, and from there we can able to access it anywhere. Each atom can be very minimal. This can take any data type. It can be a string, it can be a JSON, it can be an array, it can be a number. The strategy behind this atomic state is make individual states as small as possible so that you can easily share. Now we will see about the derived state. Derived atoms can be of 3 different types. One is like you can able to combine multiple atoms, or you can make read-only atom, or write-only atom, or read-write atom. By default, atom is read-write atom. So we will see how to combine 2 different atoms. To combine 2 different atoms, here I will create another atom named price. To demonstrate this, I will take another input, which is price. So this is like price for individual square units for fencing. Now we have 2 different values that need to be persisted here in the state. So I will change this to contain object. I will create 2 different atoms, one for side length atom. So that side length atom which is already there, that is good. So I will create another atom named price atom. So this handle-on function takes the event which comes from the input itself, and it can contain value and then the name. Based on the name which comes here, whether it can be silent or it can be price, so based on that it will get persisted into the use state. We will go back to the atom.txt. So I will create another atom. So to create another atom, just copy and paste this. Instead of side length atom, I will make this as price, and this is of number type, and the initial value for this price is 0. So go back to the input form. So here I need to set both side length as well as price. So I will create a small helper function which sets the side length and then the price. So here I will use useAtom again. So here in this case, instead of getting the side length atom, I will get the price atom, and I will use this helper function, and here instead of set side length, I will use set price and length. Now this is fine. Now we have set up the input form. Go back to the atoms.tsx. So here I want to combine these 2 atoms. So what I will do is I will create another atom, and that is a derived atom. It derives value from both side length and then price atom. Export constant fence cost atom, and this is atom. It takes 2 functions. First one is get, and which is just to get the value. If your atom is only read only, you need to provide first function. If your atom is write only, you need to make the first argument function as null. You need to provide the second function. If your atom has both read and write, you need to specify both. So here in this case, I want to make this read only. We are not persisting anything directly to the fence cost atom. Whenever there is a value changed in the side length atom or price atom, I want to see this getting changed in the fence cost atom. I will use the get side length atom into 4 get price atom. So now what we are doing is, here we are just getting the value of get side length atom, and we are multiplying it by 4. That is, we are calculating the per meter. Once we have calculated the per meter, we are getting the price atom. So this price atom is the cost to fence an individual square unit, and we are multiplying this with the per meter. So now we have this fence cost atom. So now we will create another component. I will name this as fence cost.tsx. So now what we are doing here is we are using the fence cost atom which comes from the atoms, and then we are using the useAtom function. Here in this case, we are using the fence cost which is comes from here. I need to reference this here, fence cost. So now we can able to see a fence cost also comes in. So if I put 2 here and go to input form, here in the input form, here it need to be value dot side length, because here this is no longer length. Here we are getting the side length from this value object. So now save this and go back, refresh this page. If I put 5 and then if I put 2 here, and if I set it as set side length, now we can able to see the square per meter volume. The interesting thing is it also calculates the fence cost. So that is per meter 20 into 2, which gives us 40. So now if you see, This value we are not explicitly providing. This gets computed based on the value which we have provided here. So this fence cost atom automatically computes the value based on the value stored in the side length atom and then in the price atom. So when I change this again to another value, it automatically changes. Now we will see how to create a read-only atom. This fence cost atom is already a read-only atom. That is like, we can't really change the value of side length atom or price atom because we don't have the setter function here. Now we'll make all this area, perimeter and volume as their own individual atoms, and then which computes based on the side length. I will create 3 different atoms. So these 3 different atoms are read-only perimeter atom, read-only area atom, and then read-only volume atom. Since I want to make this as read-only, I will just provide the first function. So this first function is just a get function. It gets the value and this will be triggered whenever there is a change in the side length atom. So it computes the perimeter, this computes the read-only atom, and then this computes read-only volume area. In this case, we no longer need the side length atom. We can directly take the area, read-only area atom. This is area. And go back to perimeter. Here read only perimeter atom. Remove this side length atom. Perimeter. Go back to the volume. Here read only volume atom. And this is volume. And this is input form. So here we have area, perimeter and volume. So now we have created 3 read only atoms. So this gets value from the side length atom. We can able to use this atom only to read the value. Go back to this application. Now we will change this to 5 and then this to 6. We can able to see this value are rendered correctly. So now this is how we can able to make a read only atom. So now we will see how to make a write only atom. We have used the side length atom. The side length atom, I don't want people to see the value which is being persisted here. I just want to expose only the writing capabilities. So here I have created the write only atom. So this first argument I made it as null, and then the second one gets set, and then the length. This is the value we are going to persist to this atom. And then we no longer expose this side length atoms. So go back to the input form. So here no longer we are exposing the side length atom. So this is called as write only length atom. So copy this write only length atom and then paste it here. Now we can't really see the value which is being persisted here. So now save it and go back here. Refresh this, change 54, and yeah, you can able to see the value. Now if I go back to the application and I get the length here, and here I'm gonna just put the length. So now if I go back to the application, so the length is 0. If I change the value here, yes, we can't really see any values because this is only write only. We can't really see the value which is being stored in that particular atom. But if I revert it back to the side length atom, refresh this, and then if I change it here, side length, I can able to see the value we are getting here, because this side length atom is a default atom which is both read and write. But if I made this as write only, then I can't really see the value coming out of this particular atom. So now we have seen what is write only atom. So now we will see another example. We can able to use read and write atom. So for read and write atom, it is by default. So this side length atom is by default read and write atom. So I have created a simple read write length atom. So here in this read write length atom, use the 2 functions. Here in this case for write only atom, I have made this first function as null. So this read write length atom, you are exposing the side length atom value, and then also you are giving it the capability to write. So if I use this in the input form instead of write only atom, if I use read write atom, go back to the application, refresh this. Now we can able to see the value which is being persisted in the atom. So now we will see how to persist the values to the local storage or to the session storage. Jotai provides a lot of utility function. So this persisting functionality comes with the utils function. So go to atoms.tsx, and here instead of using the simple atom, here instead of it use atom with storage. So here atom with storage, you need to provide the key and followed by the initial value. The key is the keyword which will be used in the local storage. I will go back to the application. Now inspect, go to application, and then here in the local storage we don't see any value here, but now we are using the atom with storage. So if I give 56 and then 6 here, as soon as I give 56, I can able to see this value is now persisted into the local storage. So now this value is coming from the local storage. This length is something which we are giving it as keyword here. So this is the keyword which we are getting in the local storage. So if I now refresh, so here you can able to see the fence cost is 0, but the area, per meter and the volume, everything is coming from the length. That is because this value is now persisted, and this atom by default takes the value whichever persisted in the atom with storage. I will also make this change to the price atom. Here instead of atom I will put it as atom with storage. I will mark this as price, and now refresh this and change this value 54 and then like just 65. Now we can able to see length and price got persisted. If I refresh, you can able to see all these values are returned. And next we will see about the async atoms. The async atoms you can able to use both for read functionality or write functionality. For this async atom, you can able to make use of the suspense comes with the React. You have a fallback in the suspense, so you can able to render the value whichever you are giving in the fallback, and that will be rendered once the real atom loaded asynchronously. You can able to see the real value. For this I will use a free joke API which generates random jokes. For that I will first create the joke atom. So joke atom takes in an object as an initial param. It has two different property, one is setup and another one is punchline, and I will asynchronously get the value for the joke atom. Here I will create this joke atom. So here joke object atom just reads the value from joke atom. It gets a URL and it uses the fetch functions and queries the URL and returns the response as a JSON, and that response which we are getting from fetch will be now persisted into the joke atom. And then I will create a async component. Go back to the app.tsx. So I will use atom and then the joke object atom. So this joke object atom is both read and write capability, and whenever I click a button which is generate random joke, then I will pass in this URA. So this value goes here. So this URL is the one which we are setting it through the set joke. So whenever a new URA goes in, it fetches the URA and it gets the JSON object and then it puts it to the joke atom. So now you are using this joke atom, and you will be rendering this value joke.setup and joke.punchline from here. So now we have created this async component. Now we will create the suspense. So this suspense is coming from the React. So now what happens here is I use the suspense and the atom is still fetching the value from this URA. It shows as this loading span, and once this is loaded completely, you can able to see this async component. So this async component has joke.setup, joke punchline and art. So now go back to the application, refresh this. You can able to see a new button, generate random joke. Now we got the setup and then the punchline n number of time. This is more instantaneous, but think if your API takes lot of time, it will just load the fallback, and then once the real atom loaded, then it will load the async component. With that, we have covered all the different topics in Jotai. Thanks for watching. If you really like this content, like this video. If you feel this video helped you, share it with your friends and subscribe to this channel for more technical videos. Thanks for watching.